Okay, good morning everybody, and I want to thank you for attending our current Forsyth Talk session. This is a session that I gave at Power Technical University a couple of weeks ago, and it is a session about looking at performance problems. What we're going to do with this session is we're going to look at how to avoid a performance problem, because it's more important to avoid one than what to do when there actually is one. Then we'll talk about where to start when there is a problem, and I have some information on performance tools. Since Las Vegas, I also added some slides with some sample output from various problems that I've seen. So we'll try to work through a few of those. I am going to try to have this finished in an hour and a half. It took about an hour and a quarter in Las Vegas, but as I said, I've added some slides. If you have questions, you can open the chat interface and type the questions in. I have everybody on mute during the presentation, and at the end, obviously, we'll open it up for questions as well. So again, thank you for coming to this, and I'll get the presentation started. So the first part is on avoiding problems, and there were some very good sessions by Steve Nisipany, Rosa Davidson, and a couple of other people on a number of things that you can do to avoid problems. So the first thing you have to do is understand your workload. And there's a lot of confusion when people move from Power 5 to Power 6 and then again to Power 7 about simultaneous multi-threading, when to use it, when not to use it, and what should be put in the shared processor pool and what should not. So what you really need to do is take a step back, and you have to figure out what kind of workload are we talking about. Is your workload all about speed, or is your workload all about throughput? Because Power 6 and Power 7, more and more, are all about throughput. So when we talk about speed, we're talking about distance over time. This is where gigahertz matters. It's like the fastest individual core. If you think about a single lane highway with a Bugatti Veyron driving along at 246 miles an hour, that Bugatti Veyron is going to go a very, very long distance in that time because it's got a dedicated environment and so on. But if you're talking about throughput, which is how many things can I push through in that same time frame, that's thinking more like the multi-lane highway. This is where pipelining and simultaneous multi-threading come in. And if you think about the bulk of your workloads, if you're talking OLTP with an Oracle or a DB2 or WebSphere, we're talking about throughput. This becomes more important with Power 7 than it was with Power 6, because we now have simultaneous multi-threading 4. So we're talking about trying to push through 4 things at a time on a core instead of 2, or as in Power 5, less. So I bring this up because there have been people that have moved from Power 6 to Power 7 or Power 5 to Power 7 and haven't got the performance that they were expecting, and a lot of that is because they didn't understand their workload. They had gating factors like one thread that controls all the work, or they couldn't take advantage of simultaneous multi-threading for some reason with their application. And so it is important to understand whether or not you have those kind of gating factors. So again, you have to look at your workload, and for the bulk of you, it's going to be an OLTP workload, and it's going to be based around multiple things going through at a time. So what that means is if someone comes to you and says, this is a 2.2 gigahertz system you're on, and we're going to go to a 4.4, you'll get twice the performance. They're absolutely wrong. This is because simultaneous multi-threading is based on some of the registers being duplicated, not all of them being duplicated. And we'll talk a little more about that later. So this leads into a discussion about applications on shared processor LPARs. All right. Should you put everything in a shared processor LPAR? And of course the answer is always, as with everything, it depends. So when you use shared processor LPARs, instead of getting a full core every time something gets dispatched, it gets a percentage of the core. For instance, if my entitlement is 0.5 of a core and I have 2 virtual processors, then when I get dispatched, each virtual processor will get a quarter of a core, or 2.5 milliseconds. Whereas if I am in a dedicated core, when I get dispatched, I could get the whole 10 milliseconds of the dispatch window. Why do we care about that? Well, we care about it if we have jobs that are long-running, that are speed versus throughput dependent. Because if they're speed dependent and they're long-running, then they're going to want to run for as long as possible until they either do an I/O or they run out of their dispatch window. So things that are really good candidates for the shared processor pool would include anything that's OLTP, web applications, mail servers. You can do some high CPU utilization ones, but you need to set your entitlement correctly. The real challenge is when you start to get into some of the very long-running CPU-intensive applications. Examples of this are some of the high-performance compute. SAS is one where I see it, SPSS, those kind of workloads. You may be better off running those in dedicated cores, because then you're going to get a longer dispatch window and you can push the one thing that you care about through. So just be aware that there is a difference, and what I suggest to people when they're doing some of the BI stuff is that you try it both ways. See if it runs better in the shared processor pool. And of course down the bottom I have a note that for licensing reasons, if you have databases that license based on VPs or the size of the pool, then you're going to want to use a separate processor pool for those databases. Alright, so I talked about simultaneous multi-threading. What I want to talk about now is just making sure we really understand it, because there were some changes between Power 5, Power 6, and Power 7. And this has led to some confusion about people thinking that they're actually using more cores in Power 7 than they were in Power 6. So if we look at Power 6, we had the SMT2, so we had a primary and a secondary thread. And in Power 6 and Power 5, a single thread could consume 100% of a core. So it could take the whole 10 milliseconds if there was nothing else that wanted to run. They changed those rules in Power 7 so that a single thread cannot exceed 65% utilization. What the impact of that is that in Power 5 and Power 6, it will load the primary thread and the secondary thread to 80%, and then it will unfold another virtual processor. But in Power 7, it loads the primary thread to 50%, then it will actually do the secondary thread, and then when that's at 50%, it'll dispatch tertiaries, and then it unloads another virtual processor. What it means is that virtual processors can get unfolded faster, because it will try to do primaries and secondaries across the board before it goes back and does tertiaries. So it's something to keep in mind, because what you will see if you overcommitted virtual processors in the past is on Power 6 it didn't matter because they didn't get unfolded as quickly. But in Power 7 you may be unfolding virtual processors when you have the tertiary threads still available to kick off. And that means that you're not going to be able to take advantage of proper SMT4. Whereas if you cut back on the number of VPs, you would find that you would actually use less cores, or you would appear to. There's been a lot of confusion about this. Rosa Davidson had a Back to Basics presentation in Las Vegas, and Stephen Nisipany also talked about this at great length. But this has led to a lot of confusion with customers who actually thought that they were using a lot more cores, but when they went back and looked, they actually had more idle time. So because the utilization is different and the VPs are unfolded sooner, it means in Power 7 you have to pay more attention to your virtual processors. So the recommendation to keep out of trouble is that we don't use the 10 times, or with the new Power 7 Plus, the 20 times entitlement to VP. They're recommending that a starting point now is 60% or 70% of your virtual processors. That's what you should be setting your entitlement to. And that you then increase or decrease the entitlement depending on how things go. But if you have your entitlement too low and you have a lot of virtual processors, you will now have virtual processors fighting for cores, and they'll be kicking off earlier even though you're using the same amount of CPU. And then another thing you need to think about is, and I see this all the time, running consistently above 100% entitlement. You need to get your entitlement set either slightly above what you're using on average or as to what you're using on average. Because every time you go above entitlement, you're fighting with other people for the core. And in fact, the comment that was made to me in Las Vegas was that your performance will degrade if you have more virtual processors in Alpar than you have physical processors. So that's another thing to watch out for. So the moral of the story is in Power 7, you have to pay a lot more attention to your VP to entitlement ratios than you did in 6 or 5, and that is because the point at which we kick off new VPs has changed and it happens sooner. So you want to raise that entitlement, lower your VPs, so that you don't get yourself into the situation where you're only using your primary threads because it's going to kick off VPs and then go back and use the other threads. You know, in order to get the RPerf that they quote for the Power 7, you actually need to be using all 4 threads on each core. So I just wanted to make sure that you're aware of that. And if you're not using all those threads, if you end up using, let's say, 2 out of the 4, you're going to lose about 20% of your performance. So you look at that RPerf rating and it drops. Whereas with fewer VPs, you can actually get more performance. So it's the whole throughput versus speed discussion. All right. So the other thing we have to look at where I see a lot of problems is a misunderstanding of capped and uncapped LPARs. If you cap an LPAR, let's say it's got 4 cores, if I cap that LPAR by setting the capped or setting my weight to 0, which basically caps it, then I can't exceed my entitlement. So it doesn't matter what I have for VPs or anything else. If my entitlement's 0.5 and I have 2 VPs, I can never use more than 0.5. Now, having said that, if I'm not using my entitlement, I can cede some of those back for other people to use. But it is something that you need to be aware of. And most people do understand capping, but there is some confusion about it. In the case of an uncapped LPAR, we can exceed our entitlement up to the size of the pool or the total VPs, whichever is smaller. So if you have 10 in the pool and you have 12 virtual processors, you're never going to be able to use more than 10. I would not recommend putting more VPs in than you have in the pool. Now those uncapped LPARs are the ones I was just talking about, where I need you to pay attention to your VPs to entitlement. When it comes to weights, which you have to put a weight on each LPAR, you need to keep in mind those are share-based, and this goes back to Workload Manager, which came out in AIX 433. So the example I have here is that if I have 2 LPARs that need 3 cores each, one of them has a weight of 100 and the other one has a weight of 200, then the first one would get 1/3 of the resource and the other one would get 2/3 of the resource. It's pure weights. So what you have to do is plan out your weights, and the default is 128. So what you want to make sure of is that you never put production below 128 in case somebody comes in and creates an LPAR and forgets to set the weight. So I typically set test dev to 128 or below. For my production VIO servers, I don't ever want them to have to fight too much. I might set them to 192 or even 254, and then production somewhere in between. So you kind of have to build a little table of who your most loved ones are and just prioritize them, and then make sure that there's a bit of a gap. Setting a weight does not mean, in the example here, that my prod VIO will win against prod. It means it will get a larger percentage of what is available if there isn't enough available to give both of us what we're asking for. So if we're both asking for 2 cores and 4 cores are available, we'll both get 2 cores. But if I'm asking for 2 and someone who's half my weight is asking for 2 and there's only 2 available, then we split it. All right? So the moral of this is to have a plan. Doesn't have to be this one, but to make sure you structure out who your most loved ones are and then document that and make sure that you don't put any production at 128 or below. Because if a test LPAR is brought up at 128, they're now competing for the same resource at the same priority.